Okay, so we're going to talk about the product property of nth roots. So say you have some root of AB, then you can split that up into two separate roots, like this. And I'm going to do an example here in a minute. You'll see this. It works both ways. So you can go from this to that, two separate ones, and multiply them together, or you can go from a multiplication and split them apart. Okay, so we're going to show you how to do this. This is a big part of when we simplify these radical expressions. Okay, so in example 1 here, we have the square root of 48. So I'm going to show you one way to do it, and then I'll show you another way. But what I'm going to think of is I'm going to think, hey, 48 is 16 times 3. So I have the square root of 16 times 3. But then I'm going to split them up and write the square root of 16 times the square root of 3. But I know the square root of 16, and that's why I picked 16. So some of you are probably out there going, wait a minute, back up. Why did she put 16 times 3? Why didn't she put 6 times 8 or 4 times 12 or something like that? I'm looking for a perfect square that will go into 48. I'm looking for the largest perfect square that will do that, okay? And so it was 16, and that's why I split it into 16 times 3. Okay, so the square root of 16 is 4, and so this expression simplifies. We write it like that, 4 times the square root of 3. All right, now let's go back and redo this a little bit. What if you were like, wait a minute, I didn't know 16 times 3 was 48. One thing you can do is you can take 48 and you can break it into its prime factorization. So we'll go back to the 6 times 8, right? 6 times 8 is 48. 6 is 2 times 3. 8 is 2 times 4. And 4 is 2 times 2. So if I split it all down into its prime factorization, I get that, right? So 48 is 2 times 2 times 2 times 2 times 3. Hopefully I said the right amount of 2's. All right. So this is kind of a default way of doing it. Now sometimes I do it if it's a number that I'm not really familiar with. I'll break it down into its prime factorization to do this process. And then here's the rule. Because it's a square root, for every pair on the inside, you get 1 on the outside. For every pair on the inside, you get 1 on the outside. But the 3, see, the 3 doesn't have a pair. He's all alone. Okay, so you can do it this way. I see it all the time on students' tests. Not a problem. It works really nice. And you get the same. Well, you get the same answer. Okay, so sometimes we're going to see, oh, 16 times 3, and we're going to do it that way. Sometimes we might say, I don't see what the perfect square is. Let me break it down into its prime factorization. Okay? So either way is fine. I'll probably use both methods, but there you go. We'll do some more examples.